Welcome to MLOps Live, a podcast by Neptune.ai.
We host in-depth discussions where machine learning practitioners answer questions from other practitioners about one subject related to production machine learning and MLOps.
Tune in to get real-life stories, dirty hacks, and pragmatic workarounds from ML people in the trenches. Hello and welcome back to MLOps Live. I'm Sabine, your host, and as always, joined by my co-host, Steven. Hello, Steven.
Hi, everyone. Yeah.
Hey there. With us today, joining us out of sunny Copenhagen, just kidding, great Copenhagen, we have Duarte Carmo. Welcome, Duarte.
Hi, Sabine. Hi, Stefan. How are you guys doing?
Doing great. So we'll be talking about MLOps at a small scale today, how early stage startups and small teams tackle MLOps. Looking forward to the conversation. So sometimes with our guests, I have to kind of start by asking, how does one get from astrobiology to machine learning? But Duarte, you have a pretty solid background in engineering, right?
Yeah, so I actually started as an engineer straight out of high school. So that was straight into university, and general engineering. Then I just went and funneled more and more into the more technical engineering side. So yeah, for sure. I've been in engineering most of my career. I actually started a little bit in also kind of more management strategic roles, but yeah, programming and tech were a big part of that from throughout.
And at some point you started going more in the machine learning direction, right?
Yeah, for sure. I think when I finished my bachelor and started my master's, I went to study in Denmark, where I chose this particular university because they gave me the opportunity to do whatever I wanted. So I could study whatever course I wanted. So I started going really deep into the engineering. And even though I started and worked also as in strategy and product management, I eventually just developed and continued working more and more towards the engineering, machine learning, data science side. So I would say in university is really when I fell in love with programming and machine learning, and I've been doing it since then.
Awesome. Yeah. So now you're a machine learning engineer at Ample Market, right? So it's about sales, boosting sales performance, lead generation, that kind of stuff, right?
Yeah, exactly. Actually, right now I'm a contractor. My main client is Ample Market, and Ample Market is a platform. It's first of all a platform where it helps people and it helps salespeople kind of boost sales. So it helps SaaS companies really grow through sales. So we're really kind of designing tools to make sales as efficient, effective, and powerful as possible. And machine learning is the real core of that. So we use it tremendously.
And you also do some consulting on the side.
Yeah, for sure. I mean, since early days, I've been doing consulting for startups throughout Europe. In the areas of machine learning. Sometimes it's areas more than machine learning, and I go throughout software engineering as well. But machine learning is a common thread through all of those contracts. And for sure, I love working with all different types of companies, from public-owned companies to very small startups. But startups is where I really like that niche where you can move quickly. And so, yeah, that's a big part of my work as well.
Awesome. So circling back to what's going to be our topic here today. But before we get into the questions, a bit of housekeeping from our side. So just a reminder, this is a totally interactive Q&A session. So anyone who is present with us here in Zoom can ask a question to Duarte at any time. You can raise your hand here in Zoom. We will unmute you and you can go ahead and ask, or you can type your question in chat and we'll pick it up when we find a suitable time. And this is, of course, being recorded and published later as a podcast episode, so you can catch up with it later as well. So, Duarte, to throw you our 1 minute challenge here at the start, from your perspective, what does MLOps at early stage companies look like?
I heard this challenge before.
If you had to summarize it to 1 minute.
Yeah, so for me, MLOps is about, at early stage startups, is really about delivering value quickly. I think in a lot of different companies, you have that opportunity of like, okay, you have this department for every different thing surrounding machine learning, right? You have the data engineering department, you have a bunch of other departments, but in early stage startups, a lot of times it's you and a smaller team that have to take care of most of the things. So MLOps in early stage companies looks perhaps a little bit more messy, but I would also put that it's also a little bit more exciting because I like it when things are really hard.
That fit very well inside 1 minute. So good job there. All right, Steven, over to you.
Awesome. Thanks, Duarte. To give a bit of context to that attendees, of course, what types of companies have you worked with? You've talked about working for publicly owned companies to early stage startups. Now we're going to be zooming into the early stage startups here. But I'm looking at in terms of the size of the team and the resources that were available. What's your definition of early stage in this case?
Yeah, I mean, I think that's a good question. I've worked with a lot of different companies. I've had the luck of working with a lot of great companies throughout my career, but startups is really where I thrive. And when I talk about kind of early stage, I really mean somewhere in kind of startup terms between seed and Series B, kind of scaling out. That's where I would put them. So it's regularly companies that are around, it can go from 5 people all the way to 60. It develops really quickly. And yeah, it's normally the industries can vary widely, right, Stephen? I mean, this can go from sustainability, sales, B2C, B2B throughout, but usually these types of early stage companies are either close to finding their product market fit, where they really know like, okay, this is it, or they are like starting their journey into finding that, or they already have it. So you also need to maintain that capability of shifting your product very quickly, if you know what I mean.
Yeah, definitely. We're going to be talking about a lot of those shifts as well.
Yeah.
And to start on a happy note, I would say, what's the fun thing about doing MLOps at early stage companies before we go into the war stories later on?
I mean, for me, things that are very hard to do are very fun.
Right.
That's something that I like to do. But what I would say is that things that are fun is that you have usually more control in early stage startups throughout the things that you're doing. So you don't really need to talk to a lot of different, let's say, people or inside of a company in order to implement something. You can just take an idea and just run with it. Obviously, the more experienced you are, the better this goes. So that's, for me, it's really fun. It's the fact that it's tough. It's the fact that you have much more independence on doing these things and experimenting. And another thing that I find that is really fun is that you have to do much more than just machine learning. And when we talk about MLOps, right, we talk about the whole life cycle. And I really think that early stage startups really englobe that in the way of, if you are in a super big company or an established company, you'll probably have a machine learning department with 10 machine learning engineers and 10 data scientists. Whereas if you are in an early stage startup, normally it's you and a couple of other people. Normally you don't have super fancy data engineering department giving you all those nice Kaggle data sets, which you can play around it. You normally have to really go to the trenches. And I think the trenches are fun. The final thing is that you also have to manage other things that you might not expect, right? In big companies, a lot of the things about cost are handed by you. So when you talk about cost, there's normally cloud administrators that will tell you if something is going wrong with costs. But normally, if you're in a smaller team, you're the one that owns your costs. So it's not about spinning up Kubernetes with an infinite amount of clusters. You actually need to know how much those cost, and you actually need to control those costs.
Yeah, definitely. I'd love us to zoom into the life cycle process a little bit. And usually what we see out there, and this is one of the key reasons why I think this podcast is really important, because what we see out there, these practices we see out there, this workflow processes we see out there are from like hyperscale companies like, Airbnbs, DoorDashes and everything, but we rarely see those from like early stage startup. So from your perspective, what's the machine learning and then machine learning operations workflow look like at early stage startups, from thinking about the concept of the problem to developing the proof of concept, pushing the model out there, and then operationalizing the model out there?
Yeah, I think that's a great point, Stephen. I completely agree with you. Like, you took the words out of my mouth. I think in like hyperscalers or in big tech companies, those are the ones that put the content out there, right? Those are the ones where they explain how things are done. And maybe they all do things in a similar way. Like, let's take feature store example, right? You have an open source feature store from LinkedIn, one from Meta, one other from whatever social network, right? I would say that in early stage startups, things are a little bit more heterogeneous. They're a little bit more, they're not as uniform, I would say. And yeah, things can go a little bit all directions. But if you want me to talk a little bit about how I see kind of the cycle normally, and this is how I do things, right? So I'm not saying this is the correct way. It's probably not. I normally start with people. So for me, people are really the most important thing. A lot of times you'll have machine learning departments, specifically in early stage, where people will be like, okay, build this model for me. And most of the times people don't actually need a model. They need something very different. So it's really about start talking with people, start really asking them about the problem, figuring out if this is in fact a machine learning problem and you can solve it. Another good advice that I have, even when you start, is to test internally and test quickly. So iterate and test internally if you can. So if you can proof of concept or an API really quickly out there to test it with your users. And one of my clients in Ample Markets, it's really good because we use our own tool to sell Ample Market. So I can test out a lot of the algorithms inside of that company, which is great. So, but coming back to the cycle that you mentioned, I would say like, normally I start by creating some sort of a pipeline with a heuristic before I create a pipeline with a machine learning model. I then serve that heuristic. So I do all of the logging, all of the monitoring, all the CI/CD, all of the testing using still that heuristic. So I try to deliver a heuristic from start to end so that I know that that heuristic is already serving something, right? It's not a prediction, but it's a result. Once I've done this, then it's time to improve and to create the model and really see, okay, how the model is performing. And by doing some experimentation, we can see how better the model is than the heuristic. And then since you have all of the pipeline set up, right, you can either kind of replace the pipeline, the heuristic pipeline by your model, or you can go and add different versions of that pipeline, iterate like that. Normally, that's how I start, but it depends widely on the project, of course.
Yeah, that makes sense. Walk us through the building of the proof of concepts a little bit. So you talked about heuristics being one thing. The model like development process, for example, how do you think about your proof of concepts? Let's put it that way. You could decide to pick a use case, of course, and walk us through that.
Yeah. When I decide, I can do some use cases, but for me, when I decide to build this, it's the experimentation phase is always like very experimental, let's say. So it's kind of like, okay, there's one way of us serving the models, and then there's the other way of us really building out the best model possible. And throughout building the best model possible, Stefan, I would always pay special attention to the metric definition. So do not optimize for the wrong metric. Specifically, like there are some problems, for example, let's say I'm building out a classifier, and this classifier it's an NLP problem, and the classifier classifies companies as B2B companies and as B2C companies. So companies that sell to businesses or companies that sell to consumers. Normally, one would be always like, okay, then we can just make a classifier, right? So it classifies B2B or classifies B2C, but you can also say that one company can be both B2B and B2C. So it's more, instead of a multi-class problem, is more a multi-label problem. So just this to give you an example that metric definition and problem definition are super important steps before you get started with any model experimentation. Once you have that, then do you want me to talk a little bit about more the experimentation part and how you do that, or do you prefer something else?
Walk us through the experimentation part.
So the experimentation process, normally it's really starts with understanding the problem, right? Once we understand the problem, then it's about getting a data set. And that's, again, a big difference between, let's say, the big boys and working at startups, where most of the problems in big tech and big companies, you already have the data, right? If you want to build a model, you already have that data. What happens in smaller scale startups is that you don't have that data. So you need to either build that data, annotate that data, or fetch that data from somewhere. So that's already a big difference. So we first try to get that data. Once we build out our data set, we normally always try to do some sort of testing of that data set to figure out that it's working as expected. So the outputs and the labels are all like they should be. After doing that, then it's time to go a little bit crazy with the experimentation. And I think every machine learning engineer and data scientist has a different approach to this. So even in my team, I try to give freedom of like, okay, we've defined the metric that we want to optimize. We define the problem. We have the same data set. Let's start experimenting with a couple of different algorithms, always comparing to the baseline. And normally I like to do things more of a time frame where I say, okay, we're going to experiment for a week or 3 days and let people experiment to see how much can we beat the baseline. And then also when choosing the model in the end of that week, not only we're going to choose the model that perform better in the metric, but we're also going to look at things that like how easy it is to deploy and how big the model is and how fast it performs and latency and things like that. So I like to do it kind of time-based from T0 to T1, let's say, but I think it depends widely. I don't like those, let's not put labels on it, Stefan. But I know what you mean. We can say agile, let's say.
Yeah, that makes sense. That definitely makes a lot of sense. And what you experience, what sort of models have you sort of deployed at early stage companies? Because there's always this notion that, try to deploy the simplest model, but we are beginning to see issues. Early stage startups adopt like large language models and everything. But in your case, what sort of models do you deploy?
I love simple models. Simple models are my favorites because they're so easy to deploy, right? I mean, if we look at something like Scikit, and even though, yeah, we have some problems with Pickle and Pickle is not safe and we should use other frameworks, like if you give me a Scikit model and you give me a large language fine-tuned Hugging Face classifier model, I normally would prefer this small one just because Scikit just is easier to deploy and it's a solved problem. But in terms of the problems I see in early stages is a lot of NLP, to be very honest with you. So it's a lot of NLP focus. And when we talk about NLP, we normally have a group of problems, right? Everything from classification to named entity recognition, sometimes to recommender systems, right? So I think NLP normally is multi-label, multi-class recommendation systems. And yeah, anything in terms of libraries you can see from Scikit, Hugging Face, fast text, even something custom made. So I think the APIs go a little bit through that and those types of libraries. But yeah, I've seen a lot of NLP. That's the type of models I work with. In terms of the models we use, I would say that large language models unleash a lot of power, right? And they allow us to really tackle problems that smaller models only allow us to solve with more work. And us as software engineers are a bit lazy, right? So if we can fine tune a model to perform well as a Hugging Face model, we'll normally do that, which obviously will cause problems or some problems in the deployment side. Yeah.
And I assume, of course, for an early stage startup to really focus on like NLP problems there, I know there are, like you said, there are different sets of problems, but I think two crucial problems. For example, if you're picking up like off the shelf, like BERT model, you're thinking about data quality. And then you talked about data testing. Maybe you zoom in into the data quality side, as well as how you deploy the model, because of course it needs like resources. You're probably using GPUs, or maybe you're like sort of, how do you think about data quality for such problems at early stage startups, and how do you go ahead to deploy them?
Yeah, I think data quality is a good, I mean, when we talk about large language models, data quality is an issue. I don't think, and also resources, it can also be an issue, specifically if you're training and for deployment as well. But one of the biggest issues actually, Stefan, that I would mention is the bias included in these models. At the end of the day, these models are eating up large chunks of the internet, let's just put it like that, right? And then they are doing some patterns based on, let's say, Wikipedia. The problem with that is that Wikipedia, for example, has a lot of historic biases that we already have had for years, right? So sometimes when I use those BERT models, I don't know if those biases are going to be perpetuated by the model I'm using. So that's already a concern of mine. And I would say you should be especially careful with that, specifically if you're doing some models that do some sort of sensitive things like loans or security or things like that. So I think bias and transparency in those is really important. In terms of data quality, I think, of course, when you look at the large language model, data quality maybe starts becoming less of an issue if you would work with a smaller model, just because this model is able to give you more understanding on less data. There are ways where you can leverage these large language models without a lot of data, which is also why early stage startups love them. It's because you don't have to have a 30 million row data set. You can actually have a couple of thousand examples and then use those, but squeeze all of the juice from those. So you better make sure, like you're saying, Stefan, that those 2,000 examples are really good, right? So that's really important. Finally, when we're talking about deployment, I know that you and me, Stefan, we've had some conversations about this before. You know how I feel about it. I think in terms of training, I think for us to train models, GPUs are already available in most cloud-based environments. We have, I think, perhaps Azure is the one that doesn't have those many solutions in this particular space, but I know SageMaker is a super powerful tool. We have Google Cloud and Vertex AI on the other side, which are also, they're both of them available to give you GPUs on the spot for you to train your models on. So training and fine-tuning those models should be big, quote unquote, for the ones listening. it should be easy. It's not always, but it should be in principle. Now, when it comes to inferencing and deploying those models, normally there's a couple of problems, right? Because how I like to deployment, for example, is using containers. And if you put a large language model inside of container, let's say that container is going to get very large very quickly. So you have the problem of where do you deploy that container to, right? Because you have to deployment to, I don't know, something container based. So it's definitely not an easy problem to solve. But I think with the type of models, even the models that you train with your GPU, they're actually pretty good at doing CPU-based inferencing. And you shouldn't look at only GPU inferencing. You can train on GPUs and you can inference on CPUs. And a lot of these cloud services, if you leverage them correctly, allow you to have 3 or 4 of your prediction containers running at the same time. And better than this, they allow you to have 5 or 7 or 10 containers, depending on how many containers are needed, depending on how many people are kind of asking you for predictions. So it scales super well. Instead of you like creating a machine and putting your model there, you can really leverage. So it's all about kind of leveraging the cloud in the right way, I would say, at the end of the day.
And if you talk to some early stage startup, especially the engineering team, when you talk about scale, the problem that comes to mind is, hey, my stuff is scaling. Definitely things will likely break, right? Because of the way we put things together. And another way, as an early stage startup, we want to save money, right? And if we're deploying large language models, for example, and things are scaling up pretty quickly, how do we sort of optimize the cost in that area? So how have you found these aspects relevant, and what other aspects have you found relevant, especially as these systems that scale, as you know, the startup also scales in terms of customers as well as the market they serve?
Unfortunately, and this is a mixed bag of responses, but I think the goal is to really leverage the cloud and what the cloud has to give to you. And in part of me is a bit sad in saying this, because I always also believe that we should kind of be independent of the cloud in a way. But I would say a lot of these cloud vendors actually help you solve some of the scalability issues. They allow you to kind of scale to the demand that is needed and then shrink back when the demand is not needed. Of course, that comes at a big cost, Stefan, right? So that comes at a more expensive cost that you have to control. And so I would always say that in early stage startups, we learn to leverage the cloud in the best way possible. And sometimes that comes with doing some hacks in the cloud, like turning some machines on and off, depending on how many requests you're getting. But normally, if you want something really robust, I would say that try to leverage the cloud scalability in the best way you can. Try to choose the right service. I normally, in my teams, I start doing, okay, can we do Lambda or functions as a service? If we can do a model in Lambda, let's go with Lambda. If we can't, let's go one infrastructure step slower. So let's go with PaaS. Can we deploy this in a container? Can we do it? I guess in Google Cloud is Google Cloud Run. In AWS is something like ECR, I think, or Elastic Beanstalk, something like that. And then if you can't deploy on Cloud Run because you have high memory issues, then go into infrastructure as a service, then go back to the VM and see, okay, then I'll have to assume this cost throughout the month. I'll have to set up this VM in a really good way and make sure my model runs on it correctly. I would say start as simple as you can, but if these models get really big, then start taking more and more control of your infrastructure, because that also has advantages.
Thanks for sharing that, Duarte. That's really valuable insight, I would say. And just off the back of the whole cost and scaling thing a little bit, and this is more towards your experience, I would say. Have you been in situations where you're sort of asked to see yourself forfeiting the project because, hey, a startup was asking for something and it was clearly not feasible. It wasn't really going to scale at that point because they neither had the resources or the team to execute the project?
I usually let them know before I start. So when normally we talk and they ask me for something, I let them straight away know if it's not going to work. So I try to avoid it. But normally I like difficult things, but there are difficult things and there are impossible things, right? So normally I let people know before they start. I have not yet had to kind of say no to a project or say this is impossible to do yet. But I will also tell you, Stefan, that I say no a lot, especially when the project's coming in, because I try to be selective of the things, because we are, as machine learning engineers, the specialists in our area. So we know better what problems are possible to solve or not, right? So you should be careful with what projects you accept, and you should also talk to the customer or whoever's asking you for that project and be as transparent as possible, and try not to go into into a basement, dark basement build, and then come out 20 days later saying, oh no, it doesn't work. Okay. I would say that's what I've seen, but no, not yet, to answer your question directly, Stephen. I have not had to forfeit anything yet.
Yeah, that makes sense. That makes sense. I think it will also be worthwhile to get your sort of perspective on what do you think are the most important building blocks when thinking about doing MLOps at a startup or an early stage company? What are the things that are absolutely non-negotiable to put out there before you start thinking about the project or working on the project?
When you say building blocks, are we talking about MLOps infrastructure, or are we talking about also the team of people that you're working with, for example?
Pretty much the team, the compute, probably the data, if it's not there already, or the cost or things like that.
I see what you mean. So let's start with maybe data, right? I would say in data, the problem in I like that problem, but the problem in early stage startups is that you don't have access to a lot of data sometimes, right? And the data you do have, you might not have a feature store already for you or a data engineering team. So you have to really become good at SQL. A lot of the business and software teams will have these data sets stored, and so you have to be able to take advantage of them. And unfortunately, or fortunately for some, that comes in being strong at SQL. So that's the data. In terms of the compute aspect of it, I would say that's, as I told before, and maybe it's too repetitive, but leverage the cloud as much as you can. Like, really, it's there to help you, but keep an eye on the costs, please. Don't let them explode. In terms of storage, I think storage, it's largely a kind of solved problem. I would say that storage is not as expensive or as much as a concern. There are a lot of different ways of storing assets. I would say in GCP, for example, you have things like BigQuery, you have things like buckets that you can store things on. Of course, you have all of the managed databases. Those can get quite expensive, but I would say storage is kind of a solved problem. Then we come to the talent side. I mean, the talent side is, from what I've seen, is that early stage startups, more than a machine learning engineer, want a good software engineer, unfortunately. That if you are the profile, which is fine, that you like just doing straight up data science and you like to optimize for a problem, I think maybe early stage startups are not going to excite you that much, because they expect you to do a wide range of things. I've been on teams where I'm called a data engineer and I'm writing software most of the times of like doing data engineering pretty much. So in terms of talent, I would say, really focus also on the software engineering skills. Machine learning, at the end of the day, for me, is a mix of data science and software engineering. So make sure you are good, and most importantly, that you like both. And the final one on talent is, if you don't learn, you die. I think specifically in a field like ours, there's an extreme importance in practicing, in going to conferences, listening to podcasts, going to workshops and learn, because our field is changing every day. And you see it around us, and the ones that work in the area, like it is changing massively, right? So we have to keep up, but also don't be so overwhelmed by what everyone says. So maybe don't be as concerned about what everyone else is doing and waking up one day saying, I have to have a feature store. Please make sure that you really need one before you just go out and build everything. Yeah, I would say something definitely like that.
And just a quick chip in, and what's your take on the build versus buy situation for early stage startup in terms of the tooling space?
Yeah, that's the thing about early stage startups, right? That a lot of the time people are not as worried as to build a machine learning platform, right? Depending on the startup you're working with, machine learning can or not be at the core of the problem, right? The core of the business. And so sometimes the build versus buy, I normally like to build some of the things, but let's tread lightly, right? I'm not being my own CI and CD system. So I like to build things until the point where I believe they're sufficiently important that I should delegate the management to someone else, right? But in early stage startups, you're not worried about building your machine learning platform, unfortunately. You're more worried about delivering value quickly. But your machine learning platform will converge the more projects you do. So the more projects you do with different clients, or even in the same client, your way of doing things, the way you set up a repo, the way you set up your testing, the way you set up your model monitoring, the way you set up your model retraining, these things will start emerging. And if you're not using a machine learning platform, I sometimes like to use a combination of GitHub Actions with good CI/CD, evidently for monitoring, and a couple of other tools for testing, and that works well. But I also understand that when you're in a bigger company, I mean, you just want to optimize the models quickly, right? And building your MLOps platform at scale becomes more of a concern if you have a dedicated team to it also.
Thanks for sharing that, Duarte. And I think it will also be valuable for our listeners and attendees to truly understand we've talked about the building blocks. Now, the most important MLOps components per se in like the entire workflow for early stage startup, because like you said, if I'm an early stage startup, I probably don't need a feature store, right? That's probably an overkill for the sort of use cases I'll probably be working on. But what are the most important components? Do I, as a startup, need a model registry to store that, or I could just like save my weight somewhere, load it in somehow? Or what are those really key things, in terms of testing, monitoring, and things like that?
Good points. So in the MLOps areas, right, I'm going to go a little bit more educational on the MLOps areas, but when we talk about data acquisition and data preparation, that's the first point, right? So in data acquisition and data preparation, I would say most of the times these things will take shape of some sort of pipeline. So maybe depending on the problem you have, you might need to have some pipelines in place. And this, you can go something like, tools like Airflow, tools like Prefect, a Google Cloud Composer that it's kind of basically managed Airflow can help you solve some of these problems. But this depends if data acquisition is one of the most important things for you. So for example, if you're doing a machine learning model that has to analyze millions and millions of articles every day, then building that robust pipeline is important for you. So that's acquisition and preparation, right? So pipelines of cleaning and pipelines of fetching data, where things like Spark can come in or not, is the first building block. And if that's the core of what you do, then make sure that one is done right. Then model training and model serving, right? Model training, I think model registries are great if you are iterating quickly on a model. So let me give you an example. If I have a team that is doing 8 models in 5 months, maybe they're not going to iterate as much on the models. Okay, so maybe they're going to have a couple of strong models that they're not going to be as focused as on iterating. If you have a team of 5 data scientists, then you're going to have million iterations on those models, because those data scientists are focusing on percentage point improvements on those models. And if that is the case, then, some sort of model store, like you were saying, Stefan, is extremely important. Now you can things like MLflow solve that problem really well. There's a couple of open source and some great proprietary also platforms to do that. Model serving, it also depends. Some sort of the model stores can help you solve that problem. Some of the model stores can help you solve that problem. They have serving embedded. In the cases I've seen, Stefan, the API that you're serving, the microservice that you're building, is much more than only your model. That's my problem sometimes, is that my problem, or what I always know is that people are not just, when they're querying an API, they're not only querying for your model. They're actually querying for a service. An example is, I send you an email and I want to know if you're interested in what I'm selling or not. So I want to classify an email, right? I have to make sure that when you're using this API, you're sending me the body end of the email and not the raw email. I have to make sure that I'm cleaning up that email properly. There's a whole bunch of steps that I have to do. So it's not only about just using a model framework to just serve that. I need to have some pipeline, have some data validation, etc. So yeah, perhaps it's more about also making sure you can deliver microservices consistently, and then tools like Fast API and how to serve that come really in handy. And then it's about integrating machine learning into your final product, right? So on that part, I would say it depends. Fortunately, if you have a big team of software engineers, then it's about really documenting your microservices. I love building a really nice microservice and then telling the engineering team or the software devs, like, hey guys, like I built this API for this. And they're just like, okay, the documentation is self-explanatory. We'll just go and use it. For me, that's the perfect case scenario where you don't even have to have a meeting with them for them to understand what it is. There are some cases where teams are even smaller, and where the machine learning engineer takes more responsibility into putting that onto the product. Your own team, right? So however you can serve it as the final product, you have to figure out on your own. I normally like to start with a machine learning microservice and then serving the software on the other side. So those are a little bit independent. I'm sorry, that was a mouthful, but
no. It gives a proper context. And but in terms of like the monitoring aspect of things. And do you do some monitoring? How do you do that? Do you prefer using tooling, or just
so it's a combination of things. I would say I would say from what I've seen is a stage. I think it's in terms of stages. First of all, before you go and monitor your model, you have to make sure you're kind of logging everything your model does. So the first point is make sure you have logging in place. Make sure you're storing your predictions. That's the first point. Once you're solving that problem, then you also want to kind of unravel the black box, right? And I think things like Evidently or NNML are great tools to really let you know what's happening inside of your model and really know if that drift is happening or not, and really help you know what your model is actually doing in the wild, because a lot of times that might surprise you. So a lot of times communication gets lost. So really make sure that at least you know what your model is doing. I would say for me, it's not as much as a priority as putting the model out there, but it definitely comes really close.
We have some community questions to jump onto now, but before we go into that, and how relevant have you seen automation and reproducibility for projects for early stage startups? So should early stage startups start thinking about automating their entire workflow straight away as they start working on the problem, developing proof of concepts, and building a final system, working system? Or that's something that they can think about later on, and then reproducibility as well? How would you suggest this? I think about that.
For me, there's one part of automation which is essential. I think machine learning operations is largely a field that some people will really be mad at me, but I'm going to say it is largely a side of DevOps. There is a lot of DevOps involved. And for me, starting with a good CI/CD pipeline is how I start my projects. So that's for me is automating, making sure whenever I deploy software, it goes through a certain level of checks and it deploys that software automatically. For me, that's a great thing to have. And every good project to have some sort of CI/CD in place for the deployment, for the continuous testing, for releasing a couple of versions of your model. Maybe you want to have a dev, prod, and staging version out there. And DevOps and CI/CD workflows make that incredibly easy. This is one part, a small part of the automation you're mentioning, Stefan, I know, right? There's a whole other part of automating things where you want to automate your incoming data ingestion workflows. You want to automate your continuous training pipelines. You want to automate a whole bunch of things. And I would say automate according to your needs. So don't start automating right away everything. But if you are, it's like if you are writing the same code twice, then it's a probably good indicator that you need an abstraction. But be really careful when you make that abstraction, because especially in early stages, right? Nobody's going to tell you, oh yeah, sure. Go and build all of this automation stack that our customer does not see, right? So people are a little bit more interested in actually things that directly affect the customer. And if you have to automate things to directly affect the customer and they benefit the customer, then I think you should do them. If not, then I think you should think twice.
Thanks for sharing that, Duarte. And let me jump into some of the community questions a little bit. And this person is asking, what's the best way you found to set expectations around doing projects, MLOps projects at early stage startups? How do you interact with stakeholders?
Yeah, I would say communication is key. I actually have one of the places I've worked with before is BCG, where it's kind of management, IT consulting. And one of the things I learned there is I did some IT consulting. And of course, I learned the more general aspects of IT consulting, but I also learned a lot about communication and setting expectations in your startup and in your projects early. So doubt the problem that is being put in front of you, ask a lot of questions and set expectations. And if you master communication to a certain point where you keep the person that you're working with involved, then there will be no surprises, right? Because then the person will be on your side. If you, on the other hand, like I've said before, go into the basement and disappear for 30 days, automating all of your ML pipelines, and then come out saying it was an extremely hard project, then nobody will be on your boat. You'll be surprising people. And I don't think people like to be surprising that way. So I would say communicate, iterate, and let other people know what you're doing. I think if everyone feels involved, there's less consequences and possibilities of having a surprise, especially in machine learning projects where I think there's a very popular statistic that they say that I think it's 70% of projects fail. I know you must know these statistics better than me, Stefan, but I think it's a large percentage of machine learning projects that failed, right? So especially on those, we should be careful to how we communicate it and iterate through them.
Yeah, that definitely makes sense.
Yeah.
And we have another question, and this person is asking, how much emphasis do you place on documenting your ML projects at early stage startups, especially in situations where you are like the only one working on developing and deploying models?
That's such a good question. I think documentation is a critical aspect, but do not go overboard as well, right? I mean, I've seen some pieces of documentation that they look similar to books. So whenever someone looks at a very large book of documentation, I would say maybe they're not as excited to read it, and documentation should be read. I would say also READMEs are a super good tool, where if you're setting up your project in GitHub repos, which I hope to a certain extent you are, doing some sort of code versioning, I think READMEs are a great way of specifying what the project does, how a person should get started, but in a simple way. Like if you go to a README of any good open source project, right, you'll see that there's a good amount of documentation for you to know what it does, how it does it, and what the tool is intended for, but you're not overwhelmed by that documentation, right? And if a project goes even more, then it has a read the docs. But then first it has a good README. So I try to have a good README most of the times. If the project grows to an even bigger extent, then we'll have to put it somewhere else. But normally a good README goes far away. Another thing is that it should be easy for someone to just read your documentation and get started with your project and really know, okay, git clone, here I go, let's start using this. One other thing, unfortunately, that I use a lot is actually makefiles, which I know they're a very old school tool. Nobody uses them anymore. It's something from the C# or C days. But a makefile for me is a way of me summarizing the most important commands or controls in my project. Things from running training pipelines, things from deploying that API, things from testing that API, things from running the integration or the unit tests. If they're all written in a makefile, anyone that opens that makefile can go and understand exactly what those commands are and exactly what those commands do. So for me, I found that it's a great way of adding to that documentation, saying, hey, go read that makefile because most of the common operations for this project are there.
Yeah, that makes sense. That makes sense. Thanks for
I know it's
sharing.
an old-fashioned tool, but I like it a lot.
Yeah, so this is a quick question, and this person is asking, in your experience working with early stage companies and MLOps related problems, how often have you found MLOps to be an infrastructure problem?
It's a tough question for me to solve. I mean, infrastructure is a problem. There is a time where you reach a certain scale or you want to solve some sorts of problems where infrastructure start becoming a problem. Things, I mean, just do not fit in your machine. Let's just put it like that, right? Things don't fit into RAM, things don't fit into your machine. But I don't think that is as common as people think it is. I also think that you should solve that problem once you get there. If infrastructure is in fact a problem in your case, then infrastructure is also a problem that to certain points should be solved in kind of a wider range than just machine learning. Normally in companies, infrastructure is, I hate saying this, but infrastructure architects or infrastructure engineers are actually people that are trained to think of infrastructure as at a wider level. So yeah, some things do need wider orchestration. But I think in MLOps sometimes is that a little bit like Tinder sometimes, where people have so many options that they get confused. You know what I mean? Like there are so many ways that you can use and so many different tools out there that it's hard to get overwhelmed by it. But I mean, it can be a problem. It's solve it once you get there and then figure out what solutions are out there.
Yeah, that makes sense. That makes sense. Yeah. And I think this is a really crucial question. This person asks, how do you reduce ML technical debt at an early stage startup?
Yeah, I think I heard the other day where I think I heard the other day where someone told me, like, if you don't have technical debt, you're not doing great things. You know what I mean? Like, I mean, if you're writing code and you're iterating quickly, specifically in an early startup, there will be some technical debt, and you better get comfortable with that, because technical debt doesn't mean that you're not running code quality tools and doesn't mean that you're not running tests. I mean, technical debt is something that will exist. And I've seen companies in early stage startups reach seed A, reach millions of dollars in funding, having their application with no unit tests whatsoever. So if that happens, I would say don't be worried too much about technical debt. Try to do things. But also, I mean, there's a thin line in terms of your projects and how you build them should be modifiable. So for me, what happens is the following. I try to build a project where I know that if I come back to it a week later, I'm going to feel at home modifying things and I'm going to be able to modify things. So I just try to think about that. I don't try to think about, okay, what if this API receives 3 million requests a second? I'm just worried that in the next week, when requirements might change, I will be able to go back to my code, change things that need to be changed, to go back to my model, retrain things that I need to be retrained, and then redeploy my API or do that automatically. So that's how I would kind of look at. There are also things that if your project starts growing bigger, there are things like code quality tools that really help you. There are things like linting, things like unit testing. Unit testing perhaps not, but there are things that help you control the quality of your code. And I've seen a lot of even bigger companies apply a project mentality, which is basically having a cookie cutter for repositories, and then having that cookie cutter every time you start a new project, you start with a new cookie cutter. I'm sure you've seen something like that, Stefan, where they have kind of a template for those who don't know what a template for a machine learning microservice, and then you just use that template throughout. And as I've worked with early stage startups and other companies, my template has kind of evolved. And now I have a template that I am comfortable using and employs the main things I need on my projects.
Awesome. Are you planning on sharing that on a blog post sometime? Or?
I am actually, you know, I think it would be cool because it includes a bunch of stuff. But the problem with some of these things is that there is a part of your cookie cutter that will have some dependence on the cloud vendor you're using to a certain point. It depends on how you're logging things and stuff. But I definitely think we'll work on it, Stefan. I can make a promise here. I'll put that blog post out there.
Right. I mean, we forgot to mention that Duarte is an incredible blogger as well. So that's a plus.
Incredible, I don't know, but I like to write every now and then. And yeah, I'm very opinionated in the things I write, but I think people would like it. If they like it, send me an email and let me know what you think.
Perfect. And we can end the session with that asking a really crucial question. And this is more like, what's the biggest challenge with doing MLOps at early stage companies? You know, maybe if you have war stories you can share as well, that will be helpful.
You want my war stories? I mean, I have a couple of war stories.
We all want stories. We all want war stories.
For me, anything can happen, right? I mean, but I've done some things like some things have happened where we were consuming, for example, a service, right, to fetch some news from a source, and we pay for the news that we consume from that API. And one day, that API completely blew up, and the service requests went off the charts, and we had a $4,000 bill to pay, which in an early stage startup makes a difference. And I had no clue what had happened in my code and how the hell I had made 5 times the number of requests I should. But then we understood that we were actually hacked, and actually someone had gotten our API key and they started making all of those requests. So yeah, I mean, these things normally happen a little bit more in early stage startups because it's not as a regulated environment, but it can happen. Also, I mean, for me, still the biggest challenge in early stage startups, to answer your question directly, is the fact that you have to play many more roles than you would have to play in a bigger company. And I'm comfortable with that and I like that. But if you don't like that, you also should know that you don't like it. But that's the biggest thing, and that you have to take on more responsibility. You have to take on the responsibility of testing out with your users, the responsibility of doing the cost aspect of it, the responsibility sometimes of teaching other data scientists how to write proper code, right? So you're taking out more suits, and I mean, that's largely part of the startup life. And I think that's a comfortable environment where I feel comfortable as well, to a certain extent.
We actually have at this point a question from the chat by Nick. There's multiple questions here, but let's see if we can break it up a little bit because we don't have a lot of time. But basically, Nick wants to know, how often do you use point solutions from MLOps tooling startups as opposed to building functionality from scratch when working on ML projects for your clients?
I would say that it's more common for me to build something a little bit more from scratch. I also know that I'm better at software than a data scientist, I would say. Like I like writing software, so I'm comfortable with writing software. But I also definitely see the value in these point solutions. I definitely see the value of some platform that they can take all of that responsibility. But this also comes at the cost of the flexibility of the solutions you're delivering it. So if you have the skills of building something, I would say build that. If you think it's going to become a monster really quickly and you're not prepared or don't have the experience for it, and you find a point solution that really can solve that problem, give the point solution a try as well. I mean, who is here to say you cannot try both and then go with the one you prefer, right? I think it's part of experimenting and depending what fits best for you.
Sure. And from your perspective, Nick goes on to ask here, considering how crowded the MLOps tooling startup ecosystem is at the moment, are there certain technological features that cause you to prefer one over the other, such as collaboration or security, or certain business features like experience of the founding team, amount of funding?
Yeah, I mean, yes, the MLOps system is, and the number of startups in the ecosystem is wide, and it's easy to get confused or thinking that you really need to adopt all of these solutions. There are tools out there to help you figure out what is the best stack for you and where you can build your different needs and build those stacks. There are some things that I rather pay for than build myself, and those come in a priority. I would say monitoring is something that I really like to give someone else to manage. Also, my infrastructure is something that I like to give the cloud vendors to manage that as well. So I would say there's those two for me are kind of the most important, but that does not mean that you need any specific MLOps vendor for you to help with. But I know that at a certain scale, these MLOps vendors are crucial and they really help solve an incredible amount of problems. And in bigger teams as well, aspects like collaboration and tracking your experiments with MLflow can become a lifesaver. And so I would say, yeah, look at your own specific needs, like invest in a tool when you see that things are becoming more repetitive or harder to manage.
Exactly.
But don't
Thanks
do tools for
much.
tools.
Yeah.
Yeah.
Thanks, Nick, for the question. Stephen, do you think we have time for more, or do we need to be wrapping things up?
Oh, maybe just a final question. And I think it's great that we sort of end on a good note. And Duarte, what's the single most important lesson you've learned about doing MLOps at an early stage company? If you could summarize all the experiences you've had so far, what would that lesson be?
It's a tough one to summarize. I think that we talked about a lot of different aspects, but I think I would say that don't think as much about the tools as you think about the problem that needs to be solved. Try not to get caught up in tooling. Try to get caught up in the problem that you're solving, and bring tools to help you solve that problem better. So really try to design, prototype, and once you see that you have certain needs, go and solve them with a piece of tooling. But yeah, that's why I try to keep pragmatic in the stuff that you do, and you'll see that if you shift your focus so much from tooling to how can I solve this problem in the best way possible, then tooling will follow, because there will be some things that you just can't do by yourself. And so you just start using the tooling. I would say that. That then perhaps people, as I always like to say, like at the end of the day, as machine learning engineers, what we deliver is value for people. So if people don't have a direct impact on the things that you are doing, you can ask yourself if you should be doing them.
Words of wisdom. Thank you so much for coming on and guiding us through those infamous MLOps trenches.
No worries. I hope it was helpful in any way.
Absolutely. Before we say goodbye, can you let us know how people can follow what you're doing and get in touch with you?
Yeah, for sure. My website is Duarte Carmo at duarteocarmo.com. Sorry. Duarte is do and then art with the E in the end. And then I'm also on Twitter as Duarte Carmo. And yeah, I think if you just go to my website, you'll have the links to everything. So yeah, drop by there and yeah, I mean, send me an email. I like when people email me if they read something that I said that was particularly stupid or particularly interesting.
Feedback of all kinds
is
welcome, I suppose.
Exactly.
Excellent. All right, folks. We'll be back in 2 weeks, as always, on September the 27th, next time, Tuesday, 5 p.m. Central European summertime. Yes, still summertime. And next time we'll have with us Chao Yu Yang, who is going to be talking us through solving the model serving component of the MLOps stack. So don't miss that. Will be seeing you on socials and in the MLOps community Slack in the meantime, where you can always talk to us about anything MLOps related, submit questions in advance, all that stuff. And you can catch up with past episodes on Apple Podcasts, Spotify, wherever you get your podcasts. So in the meantime, take care and thanks for joining us.
Awesome. Thanks for having me, guys. Appreciate it.
Thanks, Duarte. Bye.
Duarte.
Bye.
MLOps Live is brought to you by Neptune.ai. Remember that you can join us live at the next event and ask your questions. And you can register at neptune.ai/events.
And then make sure to search for MLOps Live in Apple Podcasts, Spotify, Google Podcasts, and anywhere you get your podcast. Click follow and don't miss any episodes.
Thanks, and see you next time.